Right, so today we're going to look at the graph of a function and its inverse. And we have a nice simple one to start off with. So we have the function f of x equal to 2x minus 1. And we have a domain restriction between -1 and 3. So to quickly calculate the range of the function, we'll just consider the values at the lower and upper boundaries of the domain. So if x was equal to 1, we would get -2 minus 1, so we'd get minus 3. And if we plugged in 3, we would get 6 minus 1, which is 5. So that tells me my range is going to be between -3 and 5. So let's consider what the inverse function would be. So we've already learned how to calculate the inverse, so we'll just change it into y equal to 2x minus 1. We'll swap x and y around, so we'll get x equal to 2y minus 1, x plus 1 equal to 2y, and so we have the inverse function equal to x plus 1 over 2. Now, we already learned about the domain and range of a function and its inverse, and we know that the domain of the inverse function is the same as the range of the original function. So the domain of this function, of the inverse, will be between -3 and 5. And likewise, the range is the same as the domain of the main function. So my range is going to be between -1 and 3. Right. Now these are simple straight lines, so that's going to make it quite easy to graph. We can just plot the 2 points on either end and join the dots. So when x is equal to -1, we get a value of -3. So -1, -3 is down over here. And then we have at +3, we have a value of 5. So at 3, we have a value of 5. And we can just join the dots. And likewise with the inverse, we can do the same thing. So at the lower end, we have x equal to -3, y equal to -1, that's down over there. And then at the other end, we have x equal to 5, and the inverse equal to 3. So that'll be over here. So we can just join the dots. Now, this shows us a very interesting property of a function and its inverse. So if I had to quickly draw in the y equal to x line, you'll notice that the function and its inverse are simply a reflection of each other about the y equal to x line. So this is my y equal to x line, and you can see that all the coordinates are just a reflection. So this coordinate here is the coordinate 3, 5, and its reflection is just where x becomes y and y becomes x. So x now becomes 5 and now y becomes 3. So that's a very interesting property about graphs of the function and its inverse. If we can graph the function, we can just reflect all the points about the y equal to x line and would be able to graph the inverse function without even having to calculate its equation. Okay? And the reason that this happens is quite simply, if we consider we have a function f and we apply the inverse to that function, by logic, the inverse function undoes what the function did, and so we should arrive at x again. And we could do it the other way as well. We could say, well, if we applied the inverse function and then the function, we would also get x. And that's why they're a reflection about the y equal to x line. Right, let's consider a different type of inverse function. And these are something that we call self-inverse functions. So let's consider the function g of x equal to 1 over x. Now, to find the inverse, we'll just do the same thing we always do. We'll change it into y equal to 1 over x. We'll remap x and y, and then we'll just resolve for y. So we'll cross multiply, we'll get that, and to solve for y you'll get 1 over x. And you'll notice that we get the same function again. So when we talk about a self-inverse function, a self-inverse function is simply where the function and the inverse are the same. Okay, so if you create an inverse function and it's the same as the function, you have a self-inverse function. And by simple logic, you can work out that this won't be a reflection about the y equal to x line. This will be a symmetrical. They will be symmetrical about the y equal to x line because they are the same function and they are basically going to create the same graph. Okay, let's use our knowledge now about the graph of a function and its inverse to work this question. So here we have the function x minus 2 squared. It's between 2 and 5. And they want us to sketch the graph of the function and its inverse, clearly showing the points on the curve where we meet the coordinate axes. Now we could calculate the inverse function and we could draw it, but we can simply graph the function and use our knowledge of how its inverse will look, how it's reflected about the y equal to x line, without even having to recalculate the function. So if we consider this function, this is just a parabola. It has a turning point at 2, 0. And so if we look, our domain actually starts at 0 or at 2. So this thing's only going to be from the turning point onwards. So the turning point is going to happen at 0. And so we're just going to plot some simple points just to give us some guidance. So at x equal to 2, we're going to get 0. And we can, since we're only going up to 5, we can just consider all the points up until 5. At x equal to 3, we will have 1 squared, which is just 1. And at 4 squared, we'll have 2 squared, which is 4. And finally, if we plug in 5, we'll get 5 minus 2, which is 3 squared, which is 9, which is up over here. And so we can simply just join the dots nice and smoothly, and there's my function. My next step would be to draw the y equal to x line. And what we're going to do is we're just going to reflect all the coordinates about this y equal to x line. So over here I have the coordinate 2, 0. And so for the inverse, it's just going to be 0, 2, which happens to be over here. For this coordinate over here, we have the coordinate 3, 1. So we're going to look for 1, 3, which is over here. This coordinate here is the coordinate 4, 4, and so it will be in the same position. And finally, this coordinate over here is the coordinate 5, 9. So I'm looking for 9, 5, which is over here. And once again, I can just join the dots. And there's my inverse function. So here's function f, and here's the inverse function. So without even having to calculate the inverse function and consider where it starts and stops, because we understand the fact that the inverse function is simply a reflection about the y equal to x line, we can graph the function and then simply remap the coordinates for the inverse function.